So now we're going to go on to the second half of all about ellipses. So in the first half of the video, we talked about what the definition of an ellipse was, how it's the same, the sum of the distances between two fixed points is always a constant, which is the k value. We talked about the major axis and minor axis, what the vertices are and co-vertices are. We have an a value, which is along the major axis. We have a b value, which is along the minor axis. And we talked about what the equations look like, depending on whether it's a short, fat ellipse or a tall, skinny ellipse. So now we're going to move on to a c value, which is in the ellipse. The c value is the distance between the center, or from the center, to one of the foci, one of the focal points. So you can see here that the c value is the distance from the center to a focal point. You notice that this a flew on the screen also. We learned before that the a value is this distance along the major axis. Well, that also happens to be the same distance from a foci to one of the co-vertices. Just to show you how that works, let me go in green. Let me start with this point here. Suppose that I went to this vertice, and then I went all the way to the other foci. Well, that distance is the same as, by the definition of the ellipse, is the same as going from the same foci to this point on the ellipse and then to the other foci. So here we have, if I go to this point here, I have 2a. That distance can be described as 2a. Here's 1a and 2a. Well, if I do it using this method, if I go from here to here, and then from this vertice back here to the center, that's 1a. But if I take my initial distance here and I add it to this distance here, well, that's another a. And so that distance is also 2a. And so this distance here, which is from the center to the vertex, is the same distance as the center from the one of the foci to one of the co-vertices. So we're going to use that idea when we go through the next problems. But let's just take a look then at how the a, the b, and the c are all related to each other. We know then that because this is a right triangle here, that b squared plus c squared equals a squared, or you can say a squared minus b squared equals c squared. I'm going to go ahead and use this relationship, that b squared plus c squared equals a squared. And that's how we can relate those three distances to each other. Let's see how this applies to our first problem. We want to find the foci of an ellipse with the following equation. Well, first, on this equation, what I'm going to do is divide everything by 3,600. So if I do that, 100 divided by 3,600 is the same thing as x squared over 36. If I take 36 over 3,600, well, that's y squared over 100. And if I take 3,600 divided by 3,600, well, that gives me 1. That means that in the x direction, I'm going to go back and forth. The square root of 36, that's a squared. So the square root of that is going to be 6. So I'm going to go over 1, 2, 3, 4, 5, 6 to the right. And 1, 2, 3, 4, 5, 6 to the left. Okay. And I put one on, and the other one disappears. And then in the y direction, that's b squared. Well, technically, I guess the 36 is b squared, and the 100 is a squared, so a would be 10. I would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then down 10. So my ellipse is going to look something like this. Well, I want to find the focal point, the foci. Well, they're going to be somewhere along the major axes, but how far? Well, we just learned that that distance can be called c. We also learned that the distance from wherever the foci is at to the co-vertices, that's a, and along the minor axis, that's the b value. And so we can use this relationship that b squared plus c squared equals a squared. I know that b is 6, so b squared is 36. I don't know what c is, so that's c squared. But I know that a is also the distance from the center to the vertex, which in this case is 10 or 100. So then I could subtract 36 from both sides. C squared is 64. If I take the square root of both sides, then c has to be 8. Well, that's helpful then, because then I know that from the center I'm going to go 8 units up. So I'm going to have a foci here at 0, 8 is one of the foci, and the other foci is at the point 0, negative 8, because I would go down 8 units from the center. Let's move on. Let's take a look at another example, number 4. So we want to write an equation for an ellipse if the foci are at plus or minus 4, 0. So here's 1, 2, 3, 4. Here's one foci. And then negative 1, 2, 3, 4, 0 is, here's another foci. And then the co-vertices are at 0, 3 and 0, negative 3. Well, that means the ellipse does something like this. We know where the co-vertices are, we know where the foci are at, but we don't know where the vertices are at. So we want to find the vertices. So I'm going to use the same relationship that we just talked about, b squared plus c squared equals a squared, and I'm going to plug in the values that I do know. I know that the b value is 3, so that's going to be 3 squared, plus the c value is 4, so that's 4 squared, and that equals a squared. So 3 squared is 9, plus 16 equals a squared. 9 plus 16 is 25, equals a squared. If I take the square root of both sides, a is 5. So that would mean my equation is going to look something like this. That means this point here has to be at negative 5, 0, and I have another point here at positive 5, 0. And so my equation is going to be x squared over 5 squared, which is 25, plus y squared over 3 squared, which is 9, equals 1. And so that's what the equation of this parabola, or of this ellipse, would look like. All right, so now we have a different situation. We have an ellipse still. Both the x squared and the y is squared, but the coefficients are different. If the coefficients were the same, it would be a circle. But here the coefficients are different, so that means one's going to be expanded. It's either going to be expanded more wide or more high, which is going to essentially stretch the circle out one way or the other to make it an ellipse. So what we want to do is graph this ellipse. Well, we're going to have to rewrite the equation first. And so what I'm going to do here is put parentheses around the 2x squared and the 8x, and I'm going to factor a 2 out. So I'm going to write it as 2 times x squared plus 4x. And I'm going to leave a space there because I'm going to complete that square, and so I can write it as something squared here in a little bit. Then I'm also going to factor an 8 out. So this is if out of these two terms. So this is going to be 8 times y squared minus 6y, and I'm going to leave a space there because I'm going to make that a perfect square. And that 8 that's here, I'm going to move to the other side. So this is going to be negative 8. But I'm going to leave 2 spaces there because whatever I do to the left side of the equation, I'm going to want to remember to do to the right side of the equation. All right, so let's complete the square here. I'm going to want to write this first one as 2 times x plus something squared. Well, half of 4 is 2. So it's going to be 2 times x plus 2 squared. Well, if this is a 2 here, I'm going to want this to be a 4 because that's 2 squared. So I added a 4 times a 2 on the left, which is adding an 8, which means I'm going to add an 8 to the right side of the equation as well. Then I'm going to go ahead and do the same thing with the y squared part. This is going to be 8. But I want to write this as y minus 3 squared. And the reason it's 3 is because it's half of the 6. But if this is a 3 here, I'm going to want this to be a 9 because that's 3 squared. And I really didn't add 9. I added 9 times 8, which is 72. So I'm going to add 72 to the right side as well. And so that means this is now going to be equal to negative 8 plus 72 is just 72. Well, that really doesn't look like the equation that we have for an ellipse. It's not a circle because these coefficients are different. And so what I'm going to do is divide everything by 72. And when I do that, I'll have x plus 2 squared, but then 2 over 72 can be simplified to just over 36. And then I'm going to have the y minus 3 squared, but 8 over 72 is the same thing as 1 over 9, and 72 over 72 is 1. And so now I'm going to graph this ellipse. The center is going to be at the point -2, +3. And I got that because the x minus 2, that shifts it 2 units to the left. The x plus 2 shifts it 2 units to the left. The y minus 3 shifts it 3 units up. So that's going to be the center of my ellipse. But then in the x direction, I'm going to go back and forth the square root of 36, which is 6. So I'm going to go over to the right. 1, 2, 3, 4, 5, 6. It's going to go through this point. And then to the left, 1, 2, 3, 4, 5, 6. It's going to go through this point. And then the y minus 3 is over 9. The square root of 9 is 3. Well, that means I'm going to go up 3, and I'm going to go down 3. And my ellipse looks something like this. All right. So it doesn't tell us to find the foci, but we should be able to figure out where the foci are as well on this ellipse. Well, let's go ahead and do that. I think that's what the next question is asking us to do. It wants to know, and this is wrong, and my red one is correct because I shifted it down before, but it should be shifted up to look like the red one. And so the next question then is asking us, can we find the foci? So I want you to imagine that this is the center, and it looks more like this. We want to figure out where the foci are at. Well, here's what we do know. I know that the A value is 6. So the A value is 6. I know that the B value is 3, but I don't know the C value. But I also know that B squared plus C squared equals A squared. Well, the B squared, that's going to be 9, plus the C squared I don't know. The A squared is 36. So I'm going to subtract 9 from both sides. So that means C squared is equal to 27, which means C is equal to plus or minus the square root of 27. So we talked in the last slide that the center is at the point -2, +3. -2, +3. Well, I'm going to move left and right this distance. So my center now is going to be, or my foci are going to be at -2, either plus or minus the square root of 27, and up 3. So -2 plus the square root of 27 would be over here somewhere. -2 minus the square root of 27 would be over here somewhere, and then it's up 3. And so that would be where my foci are at, except we know that this is going to be +2. Or no, this is negative. This is still -2. We know this is going to be +3. So hopefully that made sense. That's a little bit about ellipses. There's more practice in Canvas that you can find to get ready for your quiz. We will talk to you later.